Aluminum wiring, once common in homes, presents safety concerns. Its properties make it prone to electrical fires, risking lives and property. Aluminum has higher electrical resistance than copper. This leads to overheating and increased voltage drop. Aluminum oxidizes and corrodes over time. This forms a barrier that impedes electrical flow and generates heat. Aluminum wire expands and contracts more than copper. This causes terminals to loosen and create arcing. Arcing can ignite insulation. Aluminum wire is brittle and susceptible to breakage. This is especially true when subjected to bending or vibration. Loose connections, overheated terminals, and arcing increase fire risk. These issues can ignite the insulation surrounding the wires, leading to electrical fires. Signs of aluminum wiring problems include warm or discolored outlets or switches, flickering or dim lights, burning smells or smoke emanating from electrical fixtures, loose or broken wiring, and buzzing or crackling noises from electrical devices. If you suspect aluminum wiring, contact a licensed electrician immediately. They will verify the presence of aluminum wiring, identify any loose connections or damaged components, and determine the extent of the problem. Based on the inspection, the electrician will recommend measures such as replacing aluminum wiring with copper wiring, tightening or replacing loose connections, installing special connectors designed for aluminum wiring, and using antioxidant compounds to prevent corrosion. Ignoring aluminum wiring problems can result in electrical fires, property damage, and loss of life. Prompt action is essential to mitigate these risks and ensure safety. Aluminum wiring in residences requires professional attention. Understanding the risks and seeking timely remediation is essential to prevent electrical fires and protect lives and property. If you suspect aluminum wiring in your home, contact a licensed electrician for inspection and expert advice. Aluminum wiring poses a hidden hazard in many residences due to several inherent properties that differentiate it from copper wiring, which is now the standard. These differences create conditions that can lead to dangerous electrical problems. Firstly, aluminum wiring has a higher electrical resistance than copper wiring. This means that for a given wire gauge, aluminum will impede the flow of electrical current more than copper. Consequently, aluminum wires tend to heat up more than copper wires when carrying the same amount of current. This increased heat can degrade the wire insulation and surrounding materials, leading to a high risk of fire. Secondly, aluminum is more prone to oxidation and corrosion than copper. When aluminum is exposed to air, it forms a layer of aluminum oxide on its surface. This oxide layer is non-conductive and can impede electrical flow at connection points. Over time, this oxidation can worsen, leading to increased resistance, heat generation, and potential arcing. Thirdly, aluminum has a higher coefficient of thermal expansion than copper. This means that aluminum expands and contracts more than copper with changes in temperature. In electrical connections, this expansion and contraction can cause the aluminum wire to loosen over time, creating gaps and increasing resistance. These loose connections can lead to arcing, which is a dangerous electrical discharge that can ignite surrounding materials. Fourthly, aluminum wire is more brittle than copper wire. This makes it more susceptible to breakage, especially when subjected to bending or vibration. In residential wiring systems, aluminum wires are often bent and twisted during installation and maintenance. If the wire is nicked or damaged during this process, it can weaken the wire and make it more prone to failure. All of these factors contribute to an increased risk of electrical fires in homes with aluminum wiring. The loose connections, overheated terminals, and arcing can all ignite the insulation surrounding the wires, leading to a rapid spread of fire. Because of these risks, it's crucial to recognize the signs of aluminum wiring problems. One common sign is warm or discolored outlets or switches. This indicates that the connections behind the outlet or switch are overheating due to increased resistance. Another sign is flickering or dim lights. This can be caused by voltage drop due to increased resistance in the aluminum wiring. A third sign is burning smells or smoke emanating from electrical fixtures. This is a clear indication that something is overheating and potentially on fire. A fourth sign is loose or broken wiring, which can be visible when removing outlet or switch covers. A fifth sign is buzzing or crackling noises from electrical devices. This can be caused by arcing in the wiring system. If any of these signs are present, it's essential to contact a licensed electrician immediately. A professional electrician can conduct a thorough inspection to determine if aluminum wiring is present and to identify any potential hazards. The electrician will typically start by visually inspecting the wiring system to look for any signs of damage or deterioration. They may also use specialized tools to measure the resistance of the wiring and to detect any loose connections. If aluminum wiring is found, the electrician will assess the extent of the problem and recommend appropriate remediation measures. Several remediation options are available depending on the severity of the problem and the homeowner's budget. One option is to replace all of the aluminum wiring with copper wiring. This is the most effective solution, as it eliminates the hazards associated with aluminum wiring altogether. However, it can also be the most expensive option, as it requires a complete rewiring of the home. A second option is to install special connectors designed for aluminum wiring. These connectors are designed to provide a secure and reliable connection between aluminum and copper wires. They typically use the combination of pressure and antioxidant compounds to prevent corrosion and loosening. A third option is to use antioxidant compounds to prevent corrosion. These compounds can be applied to the connections to help prevent oxidation and corrosion. However, this is only a temporary solution and may need to be reapplied periodically. Whatever remediation option is chosen, it's essential to hire a licensed electrician to perform the work. A qualified electrician will have the knowledge and experience to properly install the connectors or replace the wiring. They will also be able to ensure that the work is done safely and in accordance with all applicable electrical codes. Ignoring aluminum wiring problems can have serious consequences. Electrical fires can cause extensive damage to a home and can even lead to injury or death. By taking prompt action to remediate aluminum wiring problems, homeowners can protect their families and their property. Firstly, the use of CO/ALR connectors is essential. These are specifically designed for aluminum to copper connections. They are different from standard wire connectors because they are designed to accommodate the different expansion rates of the two metals and to resist corrosion. Secondly, pigtailing involves connecting a short length of copper wire to the aluminum wire using a CO/ALR connector, and then connecting the copper wire to the device terminal. This creates a safer and more reliable connection. Thirdly, complete replacement of aluminum wiring with copper wiring is the most effective solution, but also the most expensive. It involves removing all the aluminum wiring and replacing it with copper wiring of the appropriate gauge. Fourthly, proper wire gauge is important. If aluminum wiring is retained, it's important to ensure that it's of the correct gauge for the circuit. Aluminum wiring generally needs to be of a larger gauge than copper wiring to carry the same amount of current. The National Electrical Code, or NEC, provides guidance on wire sizing. Fifthly, antioxidant compounds help to prevent corrosion. Applying an antioxidant compound to the aluminum wire before making connections can help to prevent corrosion, which is a common problem with aluminum wiring. Sixthly, regular inspections are important. Homes with aluminum wiring should have their electrical systems inspected regularly by a qualified electrician to check for loose connections, corrosion, and other potential problems. Seventhly, avoid overloading circuits. Overloading circuits can cause the aluminum wiring to overheat, increasing the risk of fire. Avoid plugging too many devices into a single circuit. Eighthly, be aware of the signs of problems. Homeowners should be aware of the signs of aluminum wiring problems, such as flickering lights, warm outlets, and burning smells, and should take prompt action if they notice any of these signs. Ninthly, consider professional advice. If you are unsure about any aspect of aluminum wiring, it's always best to consult with a qualified electrician who can provide professional advice and guidance. Tenthly, documentation is a good practice. Keep records of all electrical work done in the home, including any inspections, repairs, or replacements related to the aluminum wiring. This can be helpful for future reference and for potential buyers if you decide to sell the home. Aluminum wiring was primarily installed in homes between the mid-1960s and the mid-1970s. This was due to a surge in copper prices at the time, which made aluminum a more cost-effective alternative. However, the inherent properties of aluminum, as discussed earlier, make it a less suitable material for residential wiring than copper. The problems associated with aluminum wiring can arise due to several factors. One factor is the difference in thermal expansion coefficients between aluminum and the materials used in electrical devices such as outlets and switches. Aluminum expands and contracts more with temperature changes than these other materials, which can lead to loosening of connections over time. Another factor is the formation of aluminum oxide, which is a poor conductor of electricity. When aluminum wire is exposed to air, it forms a layer of aluminum oxide on its surface. This oxide layer can impede the flow of electricity at connection points, leading to increased resistance and heat generation. A third factor is the susceptibility of aluminum to galvanic corrosion. When aluminum is in contact with certain other metals, such as steel, in the presence of moisture, it can corrode more rapidly. This corrosion can weaken the wire and increase the risk of failure. To address these problems, several methods have been developed to safely mitigate the risks associated with aluminum wiring. One method is the use of copolymer connectors. These are specially designed crimp connectors that create a tight, reliable connection between the aluminum wire and a copper pigtail. The copper pigtail is then connected to the electrical device. Copolymer connectors are installed using a special crimping tool and are considered to be a permanent repair. Another method is the use of Alumicon connectors. These are screw-on connectors that are designed to provide a secure connection between aluminum and copper wires. Alumicon connectors are easier to install than copolymer connectors but may not be as reliable over the long term. A third method is the complete replacement of the aluminum wiring with copper wiring. This is the most effective solution but also the most expensive. It involves removing all of the aluminum wiring and replacing it with copper wiring of the appropriate gauge. When aluminum wiring is encountered, it's important to take a systematic approach to evaluating the situation and determining the appropriate course of action. Firstly, identify the presence of aluminum wiring. Look for markings in the wire insulation that indicate it is aluminum. Also, check the color of the wires. Aluminum wires are typically silver or gray, while copper wires are typically orange or brown. Secondly, assess the condition of the wiring. Look for any signs of damage, such as cracks, breaks, or corrosion. Also, check for loose connections at outlets, switches, and other devices. Thirdly, determine the extent of the aluminum wiring. Is it present throughout the entire house or only in certain areas? This will help to determine the scope of the remediation effort. Fourthly, consult with a qualified electrician. A qualified electrician can provide expert advice on the best way to address the aluminum wiring in your home. They can also perform any necessary repairs or replacements. The NEC provides specific requirements for working with aluminum wiring. These requirements are intended to ensure that the wiring is installed and maintained safely. For example, the NEC requires that all connections involving aluminum wire be made with connectors that are specifically listed for use with aluminum. The NEC also provides guidance on the proper sizing of aluminum wire. In general, aluminum wire must be larger than copper wire to carry the same amount of current. This is because aluminum has a higher resistance than copper.